Hello? Okay, so today we discuss, you know, uh, electricity and magnetism, no? So this is just a parang review na lang ni siya siguro sa inyo kasi I think this was tackled last semester. This is the last topic, no? We are physics 1. So we have here the electricity. Okay, so we will discuss first some topics regarding electricity. Okay. So for the introduction, so the laws of electricity and magnetism so play a central role in the operation of such devices, no, such as MP3 players, televisions, electric motors, computers, high energy accelerators, and other electronic devices. So included na rin yung cell phones, smartphones, and iba pa. No? So more fundamentally, the interatomic and intermolecular forces responsible for the formation of solids and liquids are electric in origin. So how can you say that it is related? No? So during the ancient Greeks, it was observed electric and magnetic phenomena, possibly by as early as 700 BC, no? That is 700 before Christ. And the word electric comes from electron, okay, the Greek word for amber. And so static electricity. So I think you experienced this one, parang nakukuryente ka mo or may nagapanguryente sa inyo. So it might be cause of static electricity. So you say static electricity, so these are electric charge at rest due to electron transfer. So this is usually by friction. Okay, so this is usually by friction. So a number of simple experiments, I think siguro na experiment yun during your elementary or high school days, no? So this is a demonstrated existence of electric forces. So for example, after rubbing a balloon on your hair on a dry day, so you will find that the balloon attracts bits of paper. So same goes with the comb, no? Ang suklay nyo, try nyo isuklay sa inyong buhok, mamalahan yung buhok, dry. And then try nyo ilapit nyo siya sa bits of paper, ng gisi-gisi na papel, and eventually you observe that these bits of paper attracts the balloon or to the comb, no? So this is just an example of a how electric forces exist, no? And another example is when you rub, no? This electrifies your body by vigorously rubbing your shoes on a wool rug. Let's say may mga carpet ka mo, then try nyo siya i-rub. And then eventually your feet or your shoes has now an electron, no? So the electron transfer from the carpet to your shoes. And so on your body can be detected by lightly touching and startling a friend. Di ba? So let's say may nakaptan ikaw or may narab ikaw. Then accidentally natandog mo yung mga upod or yung mga friend, no? And then parang may spark. And parang habang mo ay nag-spark, may spark pa. And so sometimes it's caused by a friction of these electric charges natin. So under the right conditions, you will see spark when you touch, and both of you will feel a slight tingle. Parang kinuryente kayong dalawa. So when materials have or behave in this way, so they are said to be electrified or to have become electrically charged. Yan tinatawag natin. So in a series of simple experiments, it was found that there are two kinds of electric charges. Okay, so ano yung dalawang electric charges na to? So which were given names, no? So these are the positive and negative. So these names given by Benjamin Franklin. And electrons are identified as having negative charge. Okay, so yung mga negative charge tinatawag nating electrons. And then yung mga protons naman, ito yung tinatawag nating positively charged. Yan. So what are the laws of electrostatics? So on the basis of these observations, we conclude that charges of the same sign repel one another and charges with opposite signs attract one another. So the same goes with the magnet. Di ba? Ano ang nag-attract gani? So the same sides or opposite nag-attract but the same nag-repel. So the same goes with laws of electrostatics. So parang magnet din siya. Yan. So we have here the law of conservation of charge. So another important aspect of electricity that arises from experimental observations is that electric charge is always conserved in an isolated space or an isolated system. Okay? So meaning, kung ano yung pinalabas mo, yun din yung ipapasok mo dapat. So walang nasasayang na electric charge. Okay? But the same principle applies, no? So it can be used to another system. Okay? But dire, it is conserved. So that is when one object is rubbed against another, so charge is not created in the process. So the electrified state is due to a transfer of charge from one object to another. So meaning nag-transfer lang siya. So one object gains some amount of negative charge, while the other gains an equal amount of positive charge. So kung ano yung inilabas nila, o kung ano yung inilabas niya, yun din yung papasok sa kanya. So that satisfies that the electric charge is always conserved. Okay, so for example, here, no? So because of conservation of charge, each electron adds negative charge to the silk and an equal positive charge naman is left on the glass rod. Okay, so when a glass rod is rubbed on a silk, so the silk obtains a negative charge. Okay, so nakakuha siya ng negative charge, but that is also equal in magnitude to the positive charge sa glass rod dito. Yan. So it is convenient to classify materials in terms of ability of electrons to move through the material. So we have, I think we have three, no? Conductors, insulators, and semiconductors. Diba? So electrical conductors, these are materials in which some of the electrons are free electrons. Okay, so that are not bound to atoms and can move relatively freely through the material. So meaning, pwede sila move freely. Unlike positive, no? Or later, check natin. So when such materials are charged in small region, the charge readily distributes itself over the entire surface of the material. Okay, so meaning, pag let's say, meron kang 1 meter na copper. 1 meter na copper. Copper is a conductor. So meaning automatically ang imong it conducts, no? Automatically it conducts electrons throughout that copper, throughout that material. So the electrons there are freely moved. Okay. How about insulators? So insulators naman, so these are materials in which all electrons are bound to atoms and cannot move freely through the material. Ito naman yung parang opposite ng conductor, which is insulator. So when such materials are charged by rubbing, only the area rubbed becomes charged and the charged particles are unable to move to other regions of the material. Okay, so for example, nirub mo yung balloon. So specific point lang of a balloon ang merong charge dyan because balloon is a rubber. Di ba? So it stands for an isolator. Yan. So not all part of the other side of the balloon, na wala mo siya ginrub sa imo hair, hindi siya makakonduct sang static electricity. Yan. So we have examples here of insulators, that is rubber, glass, oil, diamond, drywood. Yan. So semiconductors. So these are the third class of materials, and their electrical properties are between those of okay. So example of conductor might be gold, silver, aluminum, etc. And silicon, germanium, gallium arsenide, and etc. And for the glass, rubber, oil, plastic, diamond, and so on. So these are the types of semiconductors, insulators, and conductors. So you can check, or you can determine the electrical resistance of these materials, okay, based on the resistivity, or what we call the resistance ng material. Yan. So when you say insulator, so these are highly resistive, that is 10 raised to 18. And when you say the conductor, that is low, that is 10 raised to negative 10. Yan. Pero yung sa normal lang is yung semiconductor. So it might be less or more than the insulator or the conductor. Somewhat in between siya, yung semiconductor. So silicon and germanium are well-known examples of semiconductors commonly used in the fabrication of a variety of electronic chips. Mostly used in computers, cell phones, mga appliances natin. And so the electrical properties of semiconductors can be changed over many orders of magnitude by the addition of controlled amounts of certain atoms to the material. So it depends on the applications nga imo pagagamitan. So we use the silicon and germanium sa mga diode. Okay, so we have silicon diode, germanium diode. Yan, later on mabalaan nyo na siya later on sa electronics ninyo pag sa circuits yung subject. Okay, so induction. Let's go to induction. So charging an object by induction requires no contact with the object inducing the charge. Diba? So that is in contrast to charging an object by rubbing, or that is by conduction, which does require contact between the two objects. So when you say induction niya, parang lang, nasa surface lang siya pero wala siya nag-point contact gid sa duha ka object. Okay? So an example sa induction, yung mismo, yung stove, di ba? Meron tayong induction stove, electric stove na pagkaptan mo siya yan, hindi ka mapasok. Pero once na parang tawag siya may gintungtong kada sa iya nga metal, ayun. Automatically the metal hits, So dahil sa gakandak. Yan. So that's what we call the induction. Or another example siguro is yung but I think that's not an induction. The wireless charger. Okay, so let's take a look of this diagram. No? So to understand how to charge a conductor, the process known as induction. So we may consider in neutral and charge dito sa diagram na to. Okay. So let's say we have a neutral conducting sphere. So meaning it is uncharged. Ito, yung A. No? So that is conducting sphere insulated from the ground. So wala tayong connection dyan. So there are an equal number of electrons and protons in the sphere. Okay, so kung 10 na siya ka-protons, 10 man na ka-electrons da. Okay. So if the charge on the sphere is exactly 0, so when a negatively charged, let's say dito na sa part sa letter B, no? Ito yung negatively charged rubber rod. Okay, so let's say nirab natin siya dito sa sphere na yan, dito na sa letter B. Ayan. So anong matabo? So the electrons in the region nearest the rod experiences a repulsive force. Diba? So yung electrons diyan nagpalayo siya. While the positive is attracted. Okay? So when the negative charge or when a negatively charged ion rod or the rod is brought near the sphere, so the electrons in the region nearest the rod experience a repulsive force and migrated to the opposite side. So ito siya, parang nagpapalayo siya. So this migration leaves the side of the sphere near the rod with an effective positive charge. So because of the diminished number of electrons as seen in this figure. So the left side naman of the sphere, dito kung titingnan nyo, so is positively charged na siya as if the positive charge move into this direction. Sa left side siya. Kaya ang balikan natin, nag-attract siya sa opposite charge, di ba? So some of the positive charge kadto siya sa sa left side. Yan. So this process, of course, even if the rod never actually touches the sphere, niya na siya, I think ma-demonstrate yun na siya with the use of magnet. Diba? So may duwa ka magnet. So try mo isugpon ang north kag south, and then north and north and south and south. So what happens? Yun. Okay? So if the same experience is performed with a conducting wire connected from the sphere to the earth, so electrons in the conductor are strongly repelled by the presence of the negatively charged in the rod, that they move out of the sphere throughout the wire. So kung titingnan nyo dito sa letter C na yung mga negatively charged natin is parang pumupunta na siya sa baba. So this is parang grounded na siya. Okay, so these are so strongly repelled by the presence of the negatively charged in the rod that they move out to the sphere throughout the wire and into the earth. So grounded na siya. So the symbol at the end, ito, yung symbol na yan, yung parang signal na pabaliktad. Okay, so tinatawag nating ground, no? Okay, tinatawag nating ground yan, or the wire is connected to the ground, or which means that a reservoir such as earth that can accept or provide electrons freely with negligible effect on its electrical characteristics. So merong merong ibang bansa or some parts of the country diri sa Philippines that requires nga ang ilang equipment or ang ilang appliances to be grounded. So diri sa Rojas City, siguro bihira lang kamo makakita ng outlet is tatlo, in which nga yung isa is connected sa ground talaga. because the soil here in the Philippines, there is very highly conductive. Only ground, na-grounded talaga. Kasi yung wire ng yung, di ba may dalawang wire yan, yung sa kapel ko. Yung isa is yung may balat na black, yung isa is wala. So yun yung parang sa ground natin, or yan yung tinatawag nating neutral line. Okay? So dito sa sa ROHS, hindi mahina yung so malakas yung neutral line natin or ground line natin. That's why hindi na kailangan ng i-ground pa yung ibang electrical wiring natin dito. But in case, let's say sa Mindanao, sa other areas, sa Cebu, so they need to have a grounded wire. So kailangan talaga nilang three ports yung sa outlet nila. Kasi yung neutral line nila is really conductive. Mahina yung ground nila. Okay. So if the wire is to ground, distributed. Remove. Kinuha natin yung grounded wire dito sa C. So ito na tayo sa letter D. So pag kinuha natin siya, yung conductive sphere, yung sphere natin contains an excess of induced positive charge. So ano matabo? So gamay na lang aton diri nga positive charge, di ba? Kaya ang iban nga negative, gamay na lang aton nga negatively charged dire, kaya ang iban agkadto na sa ground. Kaya ang rod dire is pakadto siya, so ginrepel niya ang iban nga negatively charged. So what will happen now is ang rod nga ini, okay? So because hindi siya balanced, di ba law of conservation natin, kung ano yung nilabas, yun din yung papasok dapat. So meaning, since we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 positive charge and then we have 4 negative charge dire. So meron pa tayong 3 dito. Okay, so hindi balance yung pag-distribute ng charge natin dito. Okay, so when the rod or ano matabo dire? So ano matabo sa aton nga conducting sphere? So it contains an excess of induced positive charge because it has fewer electrons. Then it needs to cancel out the positive charge of the protons. So when the rubbing rod is removed from the vicinity of the sphere, so dito tayo sa letter E. So this induced positive charge remains on the ungrounded sphere. So natabo, manotice natin siguro nga ang negatively charged isang rod madula or nawala. Because nag-transfer na siya. Okay? So during this process, the rubber rod loses none of its negative charge. Yan. So walang nangyari dito. Diba? So na-cancel out lang. Ilan ba to? 1, 2, 4, 5, 6, 7, 8. 1, 2, 3, 4. Same pa rin. Apat pa rin. 1, 2, 3, 4. Then 1, 2, 3, 4, 5, 6, 7, 8. Yan. So the remaining electrons are distributed uniformly and there is a net uniform distribution of positive charge on the sphere. So more on positively charged na yung sphere natin. Compared dito previously na equal sila. Diba? So we have equal numbers of positive and negative charges here. But when the rod parang nag-ano siya, nirepel niya yung electrical negative charge natin sa sphere, no? Dito sa ground. Pero nang kinuha natin yung ground na to, nabawasan naman. Pero yung electric charge natin dito is undistributed or hindi uniformly distributed because of this rod na nandyan. Okay? So pag kinuha natin siya, then automatically niredistribute nila or the electrons redistributed uniformly. So, wala rin nadagdag dito. Pero nabawasan lang because of this material na nagpa-repel sa ating electrical charge. Yan. So next we have the Coulomb's law. So ano yung Coulomb's law na tinatawag natin? So Charles Coulomb measures the magnitudes of the electric forces between charged objects using the torsion balance which he invented. So ito yung representation ng torsion balance. Okay, so from Coulomb's experiments, no, we can generalize the properties of electric force, or sometimes we called it electrostatic force, between the two stationary charged particles. So we have these A and B. Okay, so these are the stationary charged particles. So from the experiment observations, we find that the magnitude of the electric force, sometimes called the Coulomb force, between 2 points charges, is given by the Coulomb's law. So recall nyo ang sa last part natin sa physics 1 that this also resembles the formula for the law of gravitational force, di ba? So that is Fe is equals to K. K is a constant. Okay, so this is the Coulomb constant multiplied by the ratio of the Q1, Q2, or these are the charges of two objects divided by the radius squared, or the radius between, or the distance between the two charges. So the value of the Coulomb constant depends on the choice of units. Okay, but here we have the SI unit that has a value of 8.9876 times 10 raised to 9 Newton meter squared per Coulomb squared. Yeah. So unit charge natin for Coulomb is T. Okay. And this constant is also written in the form K sub E. That's also equal to 1 over 4 pi E sub 0, or this is what you call the epsilon, no? Permittivity of free space, that is E sub 0. And it has a value of 8.8542 times 10 raised to negative 12 Coulomb squared per Newton meter squared. So the smallest unit of free charge E known in nature, the charge on an electron. So we have a magnitude of 1.60218 times 10 raised to negative 19. So therefore, meaning one coulomb of charge is approximately equal to the charge of 6.24 times 10 raised to 18 electrons or protons. It depends. So pag negatively charged, we have electron. Pag positively charged, we have the proton. Okay, so we have here the charge and masses of electron, proton, and neutron. Okay, so for the electron, we have the negatively charged, so that is negative 1.602. For the proton naman, we have the positively charged, so that is positive 1.602. Okay, then it depends on the mass. So electron has a mass of 9.109, while the proton has 1.672. And the neutron naman, neutron wala tayong charge dyan, zero siya because neutral nga siya. And it has a mass of 1.67493. So it's parang nearly than the proton yung mass niya. So take note, these are the constants that you will be using in computations, no, sa mga problems. Okay, ito, example natin. So the electron and proton of a hydrogen atom are separated on the average by a distance of approximately 5.3 times 10 raised to 11 meters. So these are the distance. So ito yung distance mo. Okay, saan yung ballpen dito? So let's say ito yung electric charge mo. Then ito yung positively charge mo. So yung distance natin is mula dito sa gitna, papunta dito sa kabila. So this is your R. Okay, ito yung R mo. This is the radius between the two particles. So use the Coulomb. So use Coulomb's law to find the magnitude of electric force. So we have the formula, that is K sub E, or the constant, that is multiplied by the ratio of the positively charge multiplied by negatively charge, all over by the radius squared. That is 8.99 times 10 raised to 9. So this is constant, no? Then you have 1.6 times 10 raised to negative 19, all over by 5.3 times 10. Ito na yung ano yan. Ito na yung radius natin. Okay. So ito minultiply na to eh. Okay, so that is 1.60 times 1.6, the same lang din. Diba? But of course, naka-magnitude siya, so we consider it positive. So E times E, so that is E squared na lang. So same lang din. That is 8.2 times 10 raised to negative 8 newtons. So ito yung so this is the electric force, no? Yeah. For the gravitational force, so notice we have the same formula, but in case here, no, we use the mass of the two particles. For the mass 1, we have 9.11, and for the mass 2, we have 1.67. So this is in terms of the electron and the proton mass of a hydrogen atom. Okay, so ito yung electron mass for the hydrogen, and ito yung proton mass of a hydrogen atom. Then of course we use the same what you call this one? The same radius. Okay. So you have your gravitational force of 3.6 times 10 raised to negative 47 newtons. So madali lang to. Parang review lang tayo sa sa physics 1. Yan. So application of go to so electrostatic crop sprayer. Yan. So ito yung isa sa mga application, no? So anong ginagawa dito? So a strongly charged metal wire charges the tiny droplets of pesticide as they leave the nozzle. So what will happen? So the droplets of pesticides have the same charge. So they repel each other and spread out evenly to cover a wide area. So meaning when a droplet is near a leaf, it induces an opposite charge on the leaf, and it is attracted to it. No? It is attracted to it sa leaf mismo. But pag the same charge sila, then obviously magre-repel sila. Yeah. So the droplets of a paint, ito naman example, electrostatic paint sprayer. So the droplets naman of a paint coming out from the nozzle are charged positively as the nozzle is connected to positive potential. So as the droplets of paint have some same charge, then they repel each other to form a wide fine spray. So the metal is earth, so meaning naka-ground siya, naka-grounded yung body or yung metal during spraying. And thus the droplets of paint are attracted to the metal. So giving a very even coating. Ito yung example naman sa electrostatic paint sprayer. So it saves cost, even spraying reach inaccessible parts because nag-attract ang ano. And then we have also electrostatic air. Yan. So dito naman when the fan on top spins, so the dirty air is sucked from below through a filter netting. Yung mga mesh filter tayo dyan. So bigger dirt particles are filtered off by the netting. So the dirty air then moves up through two sets of metal grids. So we have the metal grids here, the positive and negative grid. So grid A is charged positive and grid B is negatively charged naman siya. Okay. So the dust particles are charged by the grids. So negatively charged particles are attracted to the grid A, And yung positively charged dust naman, particles are attracted to grid B. So the foul smell of the air is removed through absorption of charcoal placed on top. So meaning the flows, so what flows out of the filter is the fresh clean air. And so meron tayong filter, then you have a positive and negative grid, then you have charcoal grid for the purification of air. And then we have also electrostatic precipitator. And so you remove ash and dust from the waste gases in power stations or factory chimneys before being discharged to the atmosphere. And so siguro makita nyo siya sa ibang mga factory, no? Instead of nagabugas sila sa very dark smoke, no? Yan. So mainly makikita mo is parang colorless or parang white na lang. Yan. So the smoke particles pick up negative charge, and smoke particles are attracted to the collecting plates, and then these collecting plates are knocked to remove the smoke particles. So hindi mo makita ang mga fine dust or fine ash na nagaupod, no, sa smoke. Yan. What else? So we have also photostating machine, or what we call the photocopier. So the selenium coated drum is charged positively as it rotates past a charge rod. So then the drum becomes evenly charged. So the print image are focused on the drum, and parts which receive light lost all their charges. So meaning yung dark areas on the drum surface retain their charges, and amo na siya dahil naga-imprinta sa imo nga papel. Okay? So may ginatawag kita nga ink na toner. Yan, yung parang fine na siya, fine black ink na powder siya. Okay? Which is negatively charged kag mag-attract na siya dito sa papel. Yan. Based on sa drum. Mayara na siya drum sa sulod lang mismo sa sang toner. If may nakita ka mo nga kung may nakita na ka mo nga nga photocopier nga naga-operate, no, or naga-maintenance, makita mo na siya sa sulod ang parang rolyo nga naka-rolyo yung parang drum siya. Yan. Then aramad ang toner mismo. So the toner is heated to melt the powdered ink and fix the images permanently on the paper. Yan. Parang niluluto din pala. Yan. Next, we have electric field. Yan. So ano yung electric field? So we have two fields, di ba? Electric field and magnetic field. So electric field is a region surrounding a charged body where electrostatic force can be experienced. So meron tayong tinatawag na field lines that shows direction and amount of force by how close the lines are in a positive test charge. So electric fields exert force on objects. And electric field strength, we have here, no? The formula that is E, where this is the force exerted on a charge and electric field, that is also equal to the F, or that is your force, all over by the Q, or that is your charge. Okay, so yung unit natin dito is Newton per coulomb, or what we call volts per meter. Yan. So these are the representation of electric field lines of force. So E-fields lines are constructed by determining what a positive charge would do if placed on the field. Ayan. So parang ano rin siya, parang sa magnet din siya eh. You have your North Pole and South Pole. Ayan. So ito opposite, di ba? So unlike ano sila, unlike charges, so they attract to each other. They attract. So dito, the same charge, so they repel. Yan. So nakita niyo yung field lines. Ito yung field lines natin. So the denser the lines, the stronger the field. So lines always emanate from positive charge and end at the negative charge. So meaning from positive to negative. Yung blue, yung ano natin, yung field lines natin, yung blue. So from positive to negative. Yan. So the gray dotted lines represent places where the net field magnitude is equal. Okay, dito. So note how on the parallel plate scenario, the E field is equal from any point within the plates. So nakaparallel siya, so meaning yung magnitude natin dito is equal din, no? Yan. So naka-radial din siya dito. So equal din yung pattern. Okay, so a ping pong ball coated with a conducting material. And so let's check for this example. So when a high voltage is applied across two plates, dito, so you have your insulator rod here, metal plate. So the ball is observed to be stationary. So meaning hindi siya gumagalaw. So this is because opposite charge are induced on the surface of the ball, so that the ball is attracted by positive and negative charge plates with equal amount of force. But if the ping pong ball is slightly displaced to one side, let's say naghulag lang siya gamay, what will happen? So the ball will bounce back between the two plates continuously. Okay, magbabounce yan. Kasi attract, repel, attract, repel, attract, repel. And then spreading of a candle flame. And so when the high DC voltage naman connected to plates P and Q, say it's switched on, so it is observed that the candle flame spreads out in two opposite directions. So the spread of the flame towards the negative plate is bigger. So depende sa charge particles dito. So dito, wala tayong electric field dito. Okay? But let's apply the high voltage here sa plate. Okay? So what happened? So may nagre-repel, may nag-attract pala, no? Nag-attract. So dito positively charged. So yung negatively charged ng candle nag-attract dito sa positively charged. Then dito naman sa negatively charged ng plate, yung positive charge naman ng light or ng candle yung nag-attract. So heat energy from the candle flame produces ionization of the air molecules. Positive and negative ions are formed around the flame. So positive ions are heavier and move slower. So movement of the positive ions towards the negative plate cause a bigger spread of the flame. So electrons are lighter and move at higher speed. So when they move towards the positive plate, dito sa kanan, dito sa kaliwa, so they cause a smaller spread of the flame. So ito yung reason bakit maliit lang yung ano dito, pumunta dito sa positively charged, then dito sa negatively charged malaki. Okay, so it depends or it varies, no, sa mass. Yan. Then we have lightning. Lightning. What's the relation of the electric field here? So when a negatively charged thundercloud passes above a tall building, so positive charge are induced on the roof. Yes, that's why yung mga ano natin, mga skyscraper natin, yung mga matataas na mga building, requires a natawag natin lightning rod na naka-ground siya direkta. Okay. So the same as sa mga towers natin, mga antennas natin, mga tower. Yan. So it must have a lightning rod to prevent this disaster. No? So a strong electric field between the clouds and the roof produces a strong force of attraction between the opposite charges. So electrons will suddenly accelerate from the cloud to the roof and causes the building to be struck by lightning. So a lightning conductor with sharp spikes is fixed on the highest part of the roof to reduce the risk of lightning strikes in two ways. So anong una? So the lightning conductor carries some induced charges to the ground and also cancels out some of the charges on the cloud. So this reduces the chances of lightning striking. And if lightning does strike, the lightning conductor provides an easy path for the electrons to pass to the ground without damaging the building. Okay? So that's why ginaground natin yung lightning rod natin. Or yung tatawag nating lightning arrestor. Yan. Para instead nga, let's say sa antenna mo, transmitting antenna mo, instead na yung tira. Kasi yung, di ba? So, di ba? So, meron kang tower dyan. Tapos, ito yung ano mo, ito yung antenna mo, di ba? So, ito, naka-ground to. Naka-ground yan. Naka-ground yung antenna mo, tapos ito naman, naka-connect sa device mo. Ito yung parang transmitter mo na device. Let's say, radio station. Yan. Papunta dyan. So, pag natamaan to ng kilat, so, syempre, yung kuryente, dadalo yan kung saan yung mas mabilis or kung saan yung mas madaling daanan. Diyan siya papasok. Okay? So, yung lightning rod na to na naka-ground, ito yung best path niya na pupuntahan. So, instead of striking your equipment here, because of the lightning rod na naka-abang, ito yung tatamaan niya muna. At dito siya papasok sa lightning rod papuntang ground instead of your equipment. So, in this case, safe yung equipment mo. Dito. Safe yung equipment mo. Yan. Kasi meron kang lightning rod sa taas. Yan yung purpose niya. Yan. So, questions, clarification, discussions? Bilis tayo ngayon. No? Okay. So, may recording.